Hello guys, my name is Diego Pacheco and this is another Java video. So today we will be talking about Java visibility and design. So basically there are four concerns that visibility sort of relate to, right? So the first concern, I might call it design or organization, right? So you want to organize your code in modules or packages, not only for better understanding, but also for design, right? So that's one dimension. The second dimension is about testing. You want to structure your code in a way that's easy to test, right? And depending what you do on the visibility because of your design might be better or worse to test, right? So that's the second concern. The third concern is about abstraction. And it could be a sub-part of design, right? But I want to make it explicit. Sometimes you want to hide things by design. And you want to hide it because the users cannot get it wrong if they cannot change it. So the whole idea of abstraction is to hide things, to make easier and to make it right? And the final concern, I might say, security. Sometimes you want to do things in a specific way because there's some security constraints or goals related to that, right? So we have these four dimensions. But Java, unfortunately, is very basic in sense of visibility and design. If we look on C++, for instance, in C++ you can do class level visibility. So you can specific cherry pick classes and say, hey, this class can see this, that class cannot see it. And that's done because on C++, the language has something that Java doesn't have it, which is called friendly or friend modifier. And with friendly in C++, what happens is you have this another level of granularity that we will not find in Java, and I wish Java had that. And with that, you can do a much better job on granularity in general, right? And that's what sort of a miss, right, in Java. But we can emulate it. I'm gonna show you, but let me show my screen. You see what I'm talking about, right? So we're gonna see some C++ code, and we also gonna see some Java code. So I have three POCs I wanna show you. First, we're gonna see one very simple in C++, and then we're gonna see other two in Java, right? So we can see sort of the options we have in Java. Okay, so let's get started. So here I have my VS Code, and you're gonna see some C++ code. So I have this src folder where I have my main.cpp. In here, I'm including the IO stream, sort of the standard package, and I have three classes, right? So class A, class B, and class C. Sorry for that, I clicked on the wrong place. Class A, class B, and class C. So if we look on class A, we have private and public visibility, and there's friend visibility, which is this package class level where you can cherry pick what you can see or cannot see. So for class A, we see that answer is private, so only class A can see the answer. And public, we have A here, right, that X is the answer. And we're saying that class B is friend of A. So class B is a public method show A, where you pass a reference of A, and then as you can see, we are able to call the private part of it, and this compiles and this runs, right? But for C, we cannot do that. We cannot call dot answer because it does not compile at all, right? I have autocomplete because this is VS Code, but as you can see here, it doesn't compile, right? Because it's unaccessible. And the reason of that, right, is because answer is private. So C cannot access answer, however, B can, and even being private. And the reason why is because we have this friend here. And this is the class level visibility, which I think it makes beautiful because then you can got in the sweetest spot of organization, testing, design, security, and everything. Unfortunately, we cannot do that in Java. But there are some options we can take a look, and that's what we're going to do right now. So, before I go there, let's talk about what we have in Java. So in Java, we have 4 modifiers. We have public, we have protected, or also called default package. Protected for inheritance. We have default, which is the default package, and private. And here we have class level, package level, subclass, and global. So when something is public, by default is global, meaning you have access anywhere, any subclass, any package, any class, any method. So it's completely public. Protected means you can have it in your class, in your package, in your subclass, because protected is bound to inheritance, and you cannot get global. So have the first restriction. Then you have default, which I personally use a lot. I like a lot default level. People don't use very often, but I do use a lot, and I found very, very useful. So default means you can access on a class, on a package, but subclass and global you cannot access, right? Because that's default package, and even in a different package you won't be able to use it. Although you can see this check on package, it means the same package, not the different one. And then finally, private, it only can see on your own class, right? In a different class, you cannot even see it. And you cannot see in package, subclass, or global, right? And unfortunately, in Java, we don't have friend here, so it's life. So just to illustrate that, so here we have a piece of code, and then we have the same package and different ones. So you can see that for this class called text area, get text and set text are visible for book and for my text display, because these two classes are in different packages, but because it's public, anyone can see it. And we also have this other class called text editor, which is on the same package and also can see that because it's public. But then we have something called text, which is private, and then book cannot see it and my text display cannot see it, but text editor also cannot see it, even they're on the same package or it's a different class. But then we have things which are line count and format text that are visible, and the assumption they are visible for the text editor class is because there is an inheritance going on there, otherwise you won't be able to see it. All right, and that's what we got, right? Now let's see what options besides this. There's some design things we can do in Java, right, to make it a bit better. There's some workarounds. They also have problems. I'm going to talk about the problems, right? But I want to show you guys the techniques. So I have two other Java POCs here. So let's start with this one. So here I'm using everything public, so anyone can call everyone, right? But you actually can create some protection. And let's see what this protection means in sense of design. So one thing you can do is, so I have this provider, right? This provider class. And my provider class has a beautiful method called getAnswer. The problem is provider and getAnswer are public, so anyone in the universe can call this, right? And since this is true, all right, you might want to say that some class you don't want to call it, right? Let's say the right color you want to call it, and the noisy class you don't want it to call it. So how can we protect this? Well, there's this workaround. So let me show you guys. So here you might see this on line 7 that I'm doing this thread.currentThread.stackTrace. So if we do this, we can navigate through the stack trace and we can get information from our caller. And then I'm getting 2, all right? And I'm navigating on the stack trace, all right? So on this position, I have my direct caller, and I can do a bunch of things. Like I can get the class name, the file name, the module name, the line. I can get a bunch of interesting information about the caller, but the caller. So I want to get the class name, all right? So I have a string called caller class, and then I'm just logging that in a very educational way, right? We should be using log4j here. We should not logging like that, but anyway. And then look what I can do. So I get the right caller, which is the class I want to enable to call this method. I'm getting the class and the name. I'm seeing if this is equals to the caller class. If this is equal, I'm going to perform my method and I'm going to return 42, right? And if you don't know what 42 means, you need to catch up in your geeky stuff. Otherwise, right, you are not the right caller, so you shouldn't be calling me. I'm going to throw you an exception saying, hey, you shouldn't call me. And if that, we can write some protection. And if we take a look on the right caller, the right caller just have a print call, which, get instance to the provider and ask for the answer, right? And we have the noisy class, right, who is noisy, which is exactly the same code, but this one should be doing that. And then on the main app, I just have an instance for the right caller and then try to print and call the noisy and try to print and call. But here I have a try cat because we try an exception. And if I run this, you can see this works pretty well, right? So the right caller here, we can see the log that was calling, and then we answer 42, and then we see the noisy caller calling us, and then we throw on an exception, all right? So with this, we can enforce some protection. So what can we do to make this better? Well, better is relative, right? But if you're using AOP or Spring, you can create an aspect, and you could move this to the aspect, and then you could create sort of annotation, right? So we could do it something like enable, and then you might say, okay, right caller. And anybody else, we're gonna throw an exception. Then you could create this annotation, create this generic aspect, and with that, you're gonna be able to fix it. The problem with this approach is that I personally don't like aspects. I think they are complicated and complex, and you're pushing this to runtime. All right, so that's one of the problems, and I don't think it's worthwhile doing it. This is fine. However, there's also 2 problems by doing this, right? So the first problem is in this line here, you see that I'm saying the name of the class I want to allow it, right? Because I want to do this verification. And because I did this, this generates this import here on my idea, meaning I'm generating coupling between my caller and the provider, right? So that's an unwanted coupling going on here. But because we want to do the validation, I could use this as a string, all right? So it will be less couple, but still there is a degree of coupling here, all right? Secondly, for this code, because I just have this one, right? If I have a big list, like let's say there's 3, 4, 5, 6 classes, it will be a different one, different deal. But because there's just one here, you might be wondering that, well, the provider and the caller are the only ones who need this. So I might move this code to the caller. So this 42, I might just move it from here. So I might move, I might just get the get answer here and go to the right caller, all right, and do something like this. And I might make it private, all right? So in this way, we just fix the problem, and now I can just go here and call get answer. I don't need to get from the provider, right? And this is a good smell that's showing that your design is wrong, right? But like I said, if here you have like a list with 3-4 classes, then I think this becomes more valid. There's also another drawback you need to keep in mind. You know, this validation actually is looking for a package and a class with this name. So if someone create a jar and add this there, they're gonna be able to go through your validation, right? So you might want to do more things here, but this might be able to be bypassed, right? Just because you know, it's Java, and you can do reflection, and you can do a bunch of things. You can do bytecode manipulation, right? But anyway, that's one technique I want to show you. So that's one sort of a restriction we can get and we can impose in Java without having the friend modifier like we do in C++. The second thing I want to show you guys is we actually can use design to sort of separate concerns. So imagine like you have read and write in the same place, but then you want to allow one, but you don't want to allow the another. And then you want to have sort of one being more global and the one being more restricted. That's also possible to do it. So in this use case, I create a cache just to exemplify my thoughts. So, and also I'm playing with some other interesting techniques here. This is a bit more convoluted, right? But it's also interesting technique I want to share. So let me see where I'm gonna start. Okay, so I have this cache service, all right? Of course, I'm doing a simple in-memory cache in Java. This is a singleton, so you see I have a volatile static instance. Then I have my constructor private. I have a get instance, so I'm checking if the instance is null. And then I synchronize it. Then if it's null, I instantiate. Otherwise, I return my instance, right? So classical singleton. And here I have two methods. I have a get and a set. So there's some interesting things here. So in this use case, let's say I want the get to be public, but I want the set to be only on my package. So nearby classes gonna be able to set it, and faraway classes that are in other packages, they won't be able to set it. They're only gonna be able to read it from this cache, right? So this can be done by this. First, you can see my get is public, right? So this means everybody can access. And what I do, I just receive a key and I do my inner cache, which is my concurrent hash map, right? When the key is a string and the value is a string. And I just do a get and I return, and that's it, all right? But here is the interesting part, the set, right? There's two interesting things here. The first, as you might realize, I'm using the full package, meaning it's not public, so you cannot access from other package, all right? That's the first thing. The second thing is, look the parameters. I don't have a key value. I don't have two attributes. I just have one, which is called Lazypair. And Lazypair is a generic of string, and it's called pair. And then from Lazypair, you see that the implementation I do inner cache.put, and then I do pair.getKey and pair.getValue. All right. So let's take a look on Lazypair. So Lazypair is interesting. First thing you might notice here, this Lazypair is not public. So Lazypair is the full package visibility. So meaning only this class is going to be able to instantiate this class and see and call it. So Lazypair is a generic of t, and then I have a key, which is a string, and the value going to be wherever t is. And then I have a constructor where you are forced to pass the string key and whatever t generic value is there. And then I have two getters. I have a getter for the key and a getter from the value. So this class is immutable. Once you create it, there's no turning back. And this is also lazy because when you create the values, nothing will happen. Only when you call set that I'm gonna use this value, right? So this allow you to do lazy loading, which is an interesting side effect here, and also allow me to do protection. because no one outside of this package going to be able to see Lazypair, right? I also have a public interface here called readable, because that's what I want to expose to the world, right? So readable is readable of T, I mean generic type, and then I'm saying there is a get method where you pass me a key and I'm gonna return T, right? If we go back to my cache service, you're gonna see implements readable, right? And here are implementation, there is, right? Now I created one more thing, call it cache loader. So the cache loader is on the same package. So I can use this to code bootstrap to feed this cache, right? So let's say I want to read from a database and sort of I have values there, sort of a code bootstrap logic. So I just get instance of the cache service, and then I can call the set because I am on the same package, all right? That is the full level visibility, but I am the same package, so I can do it. And also can instantiate Lazypair. And here I'm adding the values. So here I actually could do a database call, right? And this will be lazy by default because this is only gonna be called when I do the get on the Lazypair, right? So this could be completely lazy. That's the cool part of it. So I also have one more thing here, which is my readable provider, right? Because now people that are outside of this package, although the get instance is public, where it is here, right? Is public, but the class is not public. The class is the full package, right? So how can I access this cache? Well, then I create a provider. So the provider is a reader provider, right? Doesn't even give the cache away, so you don't know it's a cache. You just know that you're reading. So we are abstracting with another layer. And then here, you're gonna get a readable of a string. That's what you're gonna get, right? And there is this get method. And the only thing I do, I instantiate the cache. Sorry, I don't instantiate it. I mean, I get the instance. I might instantiate it, might not, right? Depends if the first call or not. But that's how. So this is actually a factory. So this is the factory pattern here, right? Now we can look the main method, and we can look some interesting thing. So look here. I am able to call the loader, right? Because the cache loader, it is public, all right? But I cannot access the cache because although the cache loader is public and the load is public, I cannot access the cache service, all right? Because that's not the full, that's the full package, right? So, but I can load values calling the loader. If I try to access the cache service here, this won't compile. And the import fails because this is the full package, right? But I can do the loader. And through the loader, we are able to load the cache. So we have values on the cache now. Now I can get my reader, right? It's my readable with the cache provider. And I can do the get, and this will work. But I cannot do the set. If I try to do here, first of all, I cannot even instantiate this. All right, it's not instantiable. And you see, I cannot call set, all right? Because set is not visible, and Lazypair is not visible as well, right? So this doesn't compile for multiple reasons. So there's no way I can, I cannot call, all right? So we make this protectable, right? It's protected. So I can run, and there you go. All right, it works. There is also two caveats here, 2 or 3 I want to comment, right? So one is, as you see, it is much more convoluted. However, I have some nice side effects like lazy loading. I can do code bootstrap with the loader, and I can separate reads and write, and I can decide what I hide versus what everybody can see. With reflection, you always can do interesting things in Java, right? So this protection is questionable. Although, if you look the reader, there is no parameter passing through. You know, there's nothing we are passing here, but you know, with reflection you have the instance here, although we don't have the class, all right, but you always can do stuff with reflection. But and you know, in engineering you always can hack the memory and do things on the memory, right? That's how people hack games. But anyway, I just want to show you the techniques. And wrapping up, as you saw it, C++ has some interesting visibility called friend, where you can cherry pick and do class level visibility. It's pretty cool. In Java, we don't have that. We have private, we have protected, we have public, and we have the full package. As you saw, using the extract trace, we can sort of create some validation to sort of have this class level emulation like C++ has, or we can change our design a little bit, right, and separate reads and writes, or the operations we want to expose for those we don't want. And doing that, we might be able to have some more further control. So that's it for today. I hope you guys like it. See you next time. Take care. Cheers.